Okay, look around you. Does having a glowing screen, a bunch of buttons, or just being plugged into a wall automatically make something a computer? It's a question that honestly seems super simple at first glance, but you know what? It actually trips up a lot of people. It turns out the visual clues we usually rely on, well, they might be pointing us in the completely wrong direction.
Welcome to today's Explainer. I'm your host, and today we're launching the ultimate investigation into what actually makes a machine a computer. We're going to strip away all those everyday assumptions and look at the hard evidence to solve this mystery once and for all.
Here's our official docket for today. First, we'll look at the evolution of computers. Then we'll compare thinking versus physical work before diving into the 4 computer clues. After that, we're investigating everyday objects, and finally, we'll talk about making strong classifications. Let's get right into it.
Starting off with Part 1, the evolution of computers, then and now. So, picture this. Early electronic computers, like the ENIAC back in the 1940s, were absolute behemoths. I mean, they literally filled entire massive rooms. They cost a fortune, and they had to be programmed using physical switches and cables by absolute experts. It was wild. Now compare that to modern computers. They fit right in your pocket, right? They're totally portable, they run on sleek software, and everyday people use them every single day. Visually, they have basically nothing in common. So, if we're using appearance as our main clue, yeah, that's a terrible strategy.
But what's really fascinating is what they do have in common, because despite the wild differences in how they look, all computers, from that giant room-sized ENIAC to your smartphone, share these exact 4 core characteristics. They are all machines designed for specific tasks, they follow instructions, they work with information, and they help solve problems. So while the outside changed completely, the core function, it stayed exactly the same. Moving on to Part 2, thinking versus physical work, the true difference. Here is the absolutely crucial point to remember. A computer is, at its absolute core, a machine that works with information. That's really it. Focus heavily on those 3 words, works with information. A laptop obviously does this, but surprisingly enough, so does a smart thermostat.
Now, we really need to contrast that with the definition of a machine. See, a machine is simply a device made to perform a task. Think of a bicycle, a toaster, a standard calculator. These are all machines. So it's super important to remember that while every computer is a machine, absolutely not every machine is a computer. Think about it like this. A bicycle helps move a person, and a massive crane lifts heavy objects, right? That is purely physical work. But computers? They specialize in thinking work. We're talking about organizing facts, making comparisons, and following instructions to help people make decisions. Even when a computer is controlling physical movement, like, say, a robotic arm or a self-driving car, it is only doing so by processing information and doing that thinking work first.
Which brings us to Part 3, the 4 computer clues, your detective toolkit.
If you ever want to know if something is a true computer, just run it through these 4 sequential clues. Clue number 1, is the object a machine designed to perform a task? 2, does it use information, like temperature, time, location, or maybe a user's choices? 3, does it follow instructions or rules to actively work with that information? And 4, does working with that info actually help the machine perform its task or solve a problem? If you can confidently check all 4 boxes, boom, you have found a computer doing thinking work.
All right, Part 4, investigating everyday objects. Put it to the test. Let's try this out. Is a smart thermostat a computer? Take a quick second and think about it, using those 4 clues we just talked about. Does it just turn on and off blindly, or is it actually doing thinking work? Let's break down the exact actions it takes. First off, it measures the room temperature, so it's taking in information. Next, it stores the user's selected temperature. Then it compares those 2 measurements. And finally, it actually decides when the heating or cooling should kick on by following its programmed rules. Because it's actively working with temperature info and rules to control the climate, it passes the test with flying colors. Yep, a smart thermostat is absolutely a computer. Now, what about a few other household items? Think about a robot vacuum or just a standard, plain light bulb. Can you spot the thinking work versus, just simple electricity flowing? Here is the official classification. A robot vacuum? That's a computer. It uses sensor information and programmed rules to dodge your furniture. A calculator? Also a computer. It's working with numbers and following strict mathematical instructions. But a plain light bulb? Nope, that is not a computer. Sure, it uses electricity, it gives off light, but it doesn't work with information by itself. Just having electricity, moving parts, or glowing elements definitely does not automatically equal a computer.
And finally, part 5, making strong classifications, grading your evidence.
Listen, saying it has a screen, it moves, it uses electricity, or it looks old is incredibly weak reasoning. Screens and moving parts, those are just physical traits. Electricity, just a power source. Strong reasoning requires irrefutable proof. You want to say it uses specific information and follows instructions to perform a task. You always need to look for that true evidence of information processing, not just what's visible on the surface.
Sometimes making a classification means you have to dig a little deeper. Take two microwaves that might look basically identical on the outside. A mechanical microwave might only operate through physical twist dials, meaning not a computer. But a digital microwave that uses a keypad to input time, user settings, and information, that one is very likely a computer. When the outside doesn't give you enough detail, you kind of have to leave the classification as undecided until you look at how the machine actually operates on the inside.
And here is a major trap a lot of people fall into. Keep in mind that a keyboard, a mouse, a printer, or a monitor, well, it's just a part. While a keyboard sends information to a computer, it usually isn't doing the main thinking work all by itself, right? Don't confuse an individual part with a complete thinking system. Classification requires looking at how the whole system works together.
What's genuinely fascinating to me is how basic machines can be upgraded. A standard bicycle just performs physical work. But look at a smart bicycle system. By adding sensors and programmed instructions, it can now use speed, location, distance, and even your heart rate information to assist the rider. The addition of that information processing literally changes what the system can do, upgrading a purely physical machine into a complex computing system. It's a total game changer.
So, here is our final verdict to lock into your memory from this explainer today. A computer is a machine that works with information. It's not about having a glowing screen, it's not about being plugged into a wall, and it's not about having a bunch of flashy buttons. It is entirely about processing facts, following rules, and using information to solve a problem.
Which leaves me with one final provocative challenge for you. Look around the room you're sitting in right now. Can you find a machine and use our 4 detective clues to absolutely prove whether it is a computer or not? Put your new investigative skills to the test, and whatever you do, don't let a screen or a power cord fool you. Keep questioning the world around you, and hey, thanks for joining me on this explainer.